Fiber optic connectors and splices. Fiber optical, it is nothing but two wires, just like two wires we are going to joining. Similar way, fiber optic connectors, two fiber optical cables can be connected, that is fiber joints. Fiber must be joined when you need more length than you can get on a single road, connecting distribution cable to backbone, connecting to electronic source and transmitter. For long distance communication, optical fiber cable can be connected one cable to another cable. Repairing a broken cable. Splices versus connectors. A permanent join is a splice. Joint is there, no? It is called a splice. Connectors are used at patch panels and can be disconnected. Fiber optic connectors. Requirements of a good conductor. At a connector joint, it should offer low coupling losses. There is a no loss while connecting one cable to another cables. Connectors of the same type must be compatible from manufacturer one manufacturer to another. In the fiber link, the connector design should be simple so that it can be easily installed. Connector joint should not be affected by temperature, dust, and moisture. That is, it should have low environmental sensitivity. It should be available at lower cost and have a precision suitable the application. Figure shows boot joint alignment mechanism. That is construction, straight sleeve and tapered sleeve. Two methods will be there, straight sleeve mechanism and tapered sleeve mechanism as shown in figure. Fiber optic connectors. How the two cables are connected. Boot joint alignment type connectors, straight sleeve, tapered sleeve. Then tapered sleeve mechanism is shown in the figure. Then one more is there, that is called the expanded beam connector. Transmitting fiber, receiving fiber, then collimating ions, focusing ions, then expanded beam. How these two are joined. The expanded beam controller employing collimating lens at the end of the transmitting fiber and focusing lens at the entrance end of the receiving fiber. The collimating lens converts the light from fiber into a parallel beam of light, and the focus lens converts the parallel beam of light into a focused beam of light onto the core of the receiving fiber. The fiber to lens distance is equal to the focal length of the lens. The lenses are anti-reflection coated spherical micro lenses. Fiber optic splices. A fiber optic splice is a permanent fiber joint whose purpose is to establish an optical connection between two individual optical fibers. There are two techniques used for fiber splicing: mechanical splicing and fusion splicing. A mechanical splice has a mechanical fixtures and materials that are used to fiber alignment and connection. Fusion splicing. A fusion is a fiber joint which is done by heat fuses by melting the ends of the optical fibers together. Mechanical splicing. Glass or ceramic alignment tube slices. In figure, it will be shown optical fiber two ends. One is transparent adhesive core and glass or ceramic alignment tube. Both are joined together. Fusion splicing. The process of fusion splicing involves using heat to melt or fuse the ends of two optical fibers together. Splicing process begins by repeating each fiber end for fusion. Fusion splicing requires that all protective coatings are removed from the ends of the fiber. Figure shows the basic fusion splicing apparatus consisting of two fixtures on which the fibers are mounted and two electrodes. Then optical loss, just like current carrying a conductor, how it will be, what destruction it will be there, resistance, etc. That is optical loss. That is transmission of the light due to mechanical construction of the optical fiber. Some losses are there. That is intrinsic loss. Problems the splicer cannot fix. Connectivity of fiber core or connector ferrules. Core numerical aperture mismatch, etc. The figure shows core mismatch, concentrativity, etc. Optical loss, extrinsic, that is external, that is misalignment, bad cleaves, air gaps, contamination, dirt, dust, oil, etc. Figure shows first one end gap, end angle, finish and dirt, back reflection. Optical fiber losses, that is types of attenuation, absorption loss, scattering loss, and bending loss. Now, these are the we are going to study optical emitters. Introduction to light emitting diode. A light emitting diode is a two lead semiconductor light source that converts an electrical current into light. It is a PN junction diode which emits light when activated. When a suitable voltage is applied to the leads, a light emitting diode LED is known to be one of the best optoelectronic device out of the lot. LED working. P-type material and N-type material, when we are going to sandwich or join together, some amount of energy is lost. When they are going to combine, PN junction is produced. That amount of the waste energy or amount of energy can be converted in the form of some amount of energy converted in the form of light. It is the figure P-type material and N-type material when connected to the forward bias. P-type is connected to positive terminal of the battery, N-type is connected to the negative terminal of the battery. Figure shows conduction band, then valence band, band gap, forbidden gap, while the electrons moving from valence band to conduction band, the amount of light, some energy is lost, that is in the form of light, that is light emission. Uses of LED in optical fiber. Light emitters are a key element in any optical fiber system. This component converts the electrical signal into a corresponding light signal that can be injected to the fiber. Then the characteristics of the LED, they are small, they possesses high radiance, the emitting area is small, comparable to the dimensions of optical fibers. They have a very long life, offering high reliability. They can be modulated at high speeds. Then LASER, the acronym stands for light amplification by stimulated emission of radiation. A laser device that emits light through a process of optical amplification based on the stimulated emission of electromagnetic radiation. It emits light coherently. Spatial coherence allows laser to be focused to a light spot. A laser is a coherent focused beam of photons. Laser working. Laser is created when electrons in atoms in a special glasses, crystals or gases absorb energy from an electrical current or another laser and become excited. The excited electrons move from a lower energy orbit to a higher energy orbit around the atom's nucleus. When they return to their normal or ground state, the electrons emits photons, particles of light. It light contains only one wavelength, one specific color, and laser light is directional. It is very very powerful and directional. Figure shows the comparison of LED and laser. Characteristics. One table shows characteristics LEDs laser. Output power linearly proportional to the drive current, proportional to the current above the threshold. Current, drive current, LED 50 to 100 milliampere peak, laser threshold current 5 to 40 milliampere. Coupled power moderate in LED, laser it is high, speed LED it is slower, lasers it is faster. Output pattern in LEDs higher, laser lower. Bandwidth LEDs is moderate, laser is high. Then wavelengths available 0.66 to 1.65 micrometer. In laser 0.78 to 1.65 micrometer. Spectral width wider 40 to 190 nm, that is narrower 0.00001 nanometer to 10 nanometer. Then fiber type multimode only, then it is SM, MM, easy to use, easier, harder, lifetime, longer one, long, then cost, it depends upon the, that is usually laser is very very costly. Laser diode is costly compared to LED. Next one is photodiode. That is photodiode, the name itself tells when light energy falls on that it is converted to electrical energy. Photodiode is a PN junction diode that consumes light energy to produce electric current. Sometimes it is also called photodetector. It is detects the light. A light detector and photosensor. These diodes are particularly designed to work in a reverse bias condition. It means that P side of the photodiode is associated with the negative terminal of the battery and N side is connected to the positive terminal of the battery. That is, PN junction is in reverse bias condition. Reverse bias. The figure shows the reverse bias condition. Then symbol, its characteristics. The diode is very complex to light. So when light falls on the diode, it easily changes the light into electric current. The solar cell is also branded as large area photodiode because it converts solar energy into electrical energy through solar cell works only in bright light. What is photodiode? Photodiode is one type of light detector used to convert the light into current or voltage based on the mode of operation of the device. It comprises optical filters, built-in lenses and also surface areas. These diodes have a slow response time when the surface area of the photodiode increases. Figure shows photodiode symbol. Arrow marks, incoming arrow marks indicates the light will be falls on that. It will be working. Then LED opposite one. We are showing arrow marks outward. That is, it will be emits the light working of photodiode.